We're back on our word problems. A long time ago, I gave you some pages from the textbook. Would you find those and turn to page 160? Or, if you want to pull up the PDF of the book and turn to page 160, that would be good. First thing is going to be random word problems from page 160 of our textbook. These first few are not even solved. We're not solving it. The first few, we're just writing one thing in terms of another thing. So here is what I mean. Number 15 says that the height of the right circular cylinder, so this is a right circular cylinder, and the height equals its diameter. They tell me that in the problem. Write the volume as a function of radius. Now, what that means is writing an equation for the volume in terms of the radius only. So you should know that the volume of a cylinder is pi r squared h. That's the formula for the volume of a cylinder. Now, notice that in this formula for volume, there are two variables, r and h, which is fine, except this problem says you're only to have r's. So what you do is go back into the problem and look at the additional information they provided. They told me in this particular problem that the height is equal to the diameter. And we know that diameter is 2 radiuses. Would you agree with that? So now the problem with this was I was only supposed to have r's. So now I can take this h out and replace it with 2r. So volume is pi r squared times 2r, which simplifies to 2 pi r cubed. So here's the deal. You guys that are going to take calculus are going to have to do this a lot, because most formulas involve more than one variable. And when you're doing calculus with it, you want only one. So you're going to be doing this kind of substitution a lot. They told me that the height was 2 radiuses, so I'll just take out my h and replace it with 2r. And now I have exactly the same formula, but it's only in terms of r. All right, let's try the next one. One leg of a right triangle, and remember, when we talk about the legs of a right triangle, we're talking about the two that make the right angle. These are the legs. That's the hypotenuse. One leg of a right triangle is twice as long as the other. So does that setup make sense to you? Write the length of the hypotenuse as a function of the length of the shorter leg. This is the shorter leg. So in other words, I have to write the hypotenuse in terms of x. Well, what do I know about the hypotenuse? It's a squared plus b squared equals h squared. So h squared equals x squared plus 2x squared. Would you agree with that? So h squared equals x squared plus, be careful here, this is actually going to be 4x squared. Would you hear it? So h squared equals 5x squared. Now that's beautiful, except it's not the hypotenuse, it's the hypotenuse squared. So I need to get just h. How am I going to get just h? What am I going to have to do? Square root. And be careful when you square root it. H is going to be x square root 5. Would you agree with that? Because when I square root 5, I can't do anything, but the square root of x squared is x. And we normally write it like that instead of like this. Do you know why? Do you know why it's usually not written this way? It's usually written this way? Because if you make this line just a little bit too long, then you don't know where that x is, right? So normally if it's not in the radical, it goes out in front, just to make sure you're straight on that. Okay, 17. The base of an isosceles triangle, I have an isosceles triangle, and this is called the base, is half as long as the two equal sides. Write the area of the triangle as a function of the length of the base. Now, there are a couple ways you could set this up, but since it says that my equation has to be as a function of the length of the base, this is going to be x, because that's the base. So my variable is the base. Now, what does that make these two sides? What does it say? 2x. It says the base is half as long as the legs. So if I made the base x, then the legs are 2x. Write the area of the triangle. And wait, what's just the overall general formula for the area of the triangle? 1/2 base times height. Right? Okay. What's the base? X. That's good. Would you agree that's the height? How in the world are we going to find the height? I can do the Pythagorean Theorem again. Sure I can. Isn't that a right triangle right there? Now, here's what you gotta be careful about. I know that the hypotenuse is 2x. I got my a squared and my b squared, and I know this is going to be 2x squared, because that's what the hypotenuse is. What's this? Half x. So half x squared, right? Half x squared plus h squared equals 2x squared. Now remember, in this problem, you are trying to make your formula only have x's. Well, it has an h. But are we going to be able to figure out what h is from this equation? And then plug it in down here. That's what we're going to do. So, what's 1/2 x squared? 1/4 x squared. Beautiful. 2x squared is 4x squared. Now what? Subtract the 1/4. So h squared is 4x squared minus 1/4 x squared. Now, don't you dare start panicking. You guys, come on now. What's 4 minus a 4th? Well, we can say 3 3/4. That's a little unhandy to be taking the square root of here in a minute. So instead of 3 3/4, maybe we'll say 15/4. So what is H? Okay, simplify that for me. Can I do anything with the 15? So it's going to stay root 15. How about the 4? 2. How about the x squared? I'm square rooting it. Isn't it just x? Or x root 15 over 2? Please don't get bogged down in fractions, guys. You guys can do this. All right, now, where's my area formula? Right here. So what's H? X root 15 over 2? Well, there's your answer. Just clean it up a little bit. So what are we going to have? Our area is going to equal, straight across the top, what do I have? 1 times x root 15. X squared root 15. And what's on the bottom? 2 times 1 times 2. There it is. That's the area of the triangle in terms of x. All right, we'll do one more of these. And then we're going to go down and do some of the ones that actually are problems. All right, number 18. A square is inscribed in a circle. Does anybody know what that means? A square is inscribed in a circle. So there's your circle, and then your square just fits in there perfectly. We want to write the area of the square as a function of the radius of the circle. So here's the radius of the circle. Notice I drew it to this corner. I could have drawn it across this way, but that isn't going to suit my purposes. So I need to keep it in the square here. If you want the area of the square, don't you really just need to know what these sides are? Could I do that? And since this is a square, that's a right angle right there. Oh, I'm sure that's one of those obscure things you've forgotten. But the diagonals of a square are perpendicular. Actually, the diagonals of any rhombus are perpendicular. I know. It's true. If this is a right triangle, guys, can't we do the Pythagorean Theorem again? So r squared plus r squared equals s squared. Would you agree with that? Now keep in mind, the area of the square is s squared. So isn't s squared 2r squared? So what's the area of my square? The area of my square is simply 2r squared. I know what's going through your head. I know what you're thinking. I can't do this by myself. Yes, you can. Yes, you can. Don't panic and don't worry about it. We will get through it, I promise. All right, let's look at number 28. This might be the last one we do. We might get one more on this, but number 28. Ruth is rating 2 job offers from the sales departments of 2 competing companies. One offers a base salary of $25,000 plus 5% commission. The other offers a base salary of $20,000 plus 7% commission. What would Ruth's sales have to be to make the second job offer more attractive than the first? Okay, this could be a real life problem for you guys when you go out to get a job. Do you understand how commission works? Commission means you get a percentage of what you sell. So this is your base salary, but then she's going to get 5% of everything she sells. This is a smaller base salary, but a higher percentage. So do you understand at some point it's going to become more lucrative for her to take less upfront money because she's going to sell a whole bunch of stuff? Okay, so your job is to find that tipping point. What is it? How much does she have to sell to make these the same? Because anything after that will make this the best deal. All right, so how do you think we'll set this up? Katie?
It would just be like 25,000 plus 0.05x, and then set that equal to 20,000 plus 0.07x.
Perfect. X is however much she sells. So Katie said, I'm going to take 5% of X and add it to the base salary, and 7% of X and add it to that base salary. Okay, that's easy enough. So solving this equation, this is not a big deal. I should be able to do that in my head. 250,000? Is that what you got? So how much will she have to sell to make the second job offer more lucrative? More than 250,000. If she sells 250,000, they're the same. More than that, this will be the deal. Everybody okay with that? All right, nice job, Katie. One more, here we go. Last one for today, number 31. We did these when you were freshmen. You did them when you were freshmen. Number 31, it's a mixture problem. And what's happening is you've got 2 different mixtures, you're mixing them together, coming up with a third mixture. So it's kind of like if you made Kool-Aid at home and it was too strong, you dumped in some extra water to weaken it out, you're mixing those solutions to come up with a desired result. There are different ways of approaching it. I have found that the easiest way to do these mixture problems is just to use this format. It is so easy. Here's what it means. Take the amount of your first solution times its percentage. Add the amount of the second solution that you're mixing in times its percentage. And that will give you the final amount and the final percentage of your mixture. So for this problem number 31, I know that I am mixing a 10% solution and a 45% solution. And I am ending up with a 25% solution. Those are my percentages. Would everybody agree with that? Now, what are my amounts? Well, I know I'm ending up with 100 gallons. It tells me that in the problem. Right? I know that I want to figure out how much 10%, so I'll call that X. It says how much 10%. And how much of this, now I gotta be careful, because I can't call this X. Because if I did, that would mean that my amounts were equal, and I don't know that. So do you have an idea what I might call it if I can't call it X? Well, I could call it Y, but now I got a problem. I have a bunch of variables now. But what do you know about X and Y? What do you know about these two? Added together, don't they have to give you 100? And if X plus Y have to be 100, remember, here's my bucket. I'm dumping in X of this and Y of this, and it's equaling 100. Doesn't that mean that Y is 100 minus X? Is that right? So I'm going to put that right here. I'm going to make this 100 minus X. And now I only have one variable, and I can solve this equation. So 0.10x. Do my distributive property there. Hopefully I am multiplying right. We're running out of time, so I'm kind of rushing. Haste makes waste. Hopefully I'm not messing it up. I got 57.14 gallons. Now, I don't know if that's right or not. Did anybody else get that? 57.14 gallons of what? What's this of? What's X? X is the gallons of 10%. So then how will I get the gallons of 45%? 100 minus it. Yeah, 100 minus it. So 42.86 gallons of 45%. Now I know I did that really, really fast. Does anybody have a quick question about something going on here? Amount times percent plus amount times percent equals final amount times percent. Anybody that didn't get pictures of these practice graphs, feel free to get them right now.